Hello, Year 14. In this review lesson, we're going to look at linked lists and paying particular attention to the past paper question. So if we begin with looking at explaining what a linked list is and highlighting advantages and disadvantages, I'm just going to do this in shorthand. We're looking for appropriate technical vocabulary. It is a dynamic data structure. So you should have started that, the idea that it's a dynamic data structure. What does this data structure contain? You should have explained that there is elements, a list, set of nodes. So I think it would be fair to say that there's a list, a set of nodes, and then you want to say what each of these nodes are. A node contains the data and a pointer. So you've got plenty of technical vocabulary in there to award 2 marks. A dynamic data structure that consists of a list or a set of nodes. The nodes have got a data and pointer. So if you have 2 clear marks out of that. Next, if we look at its advantages. So I'm going to click plus. Main one is constant time access. Sorry, constant time, not access, constant time insertions and deletions. Doesn't matter what size the linked list is, inserting and removing a node is the same set algorithm, it's constant. The other big plus is an efficient use of memory, because unlike an array, it doesn't use a contiguous block of memory. So if you mention memory efficiency, efficient use of memory, there would be a mark point there. I'll put it down as memory efficient. So we look at the negatives and we're looking at it's complex to program or implement. Shorthand, I'm just going to say complex. And the other big downside is searching. It's a linear search, which you know is inefficient. So in shorthand, I'm just going to put down linear search stroke inefficient. So there's plenty there to get your 4 marks. Next, we move on to understanding the pointers on a linked list, and we've been asked to sort this in ascending numerical order, and the lowest number, 752, gives me this value here. So bear with me, hopefully I can get this correct. 2, 1, 23. I'm looking for, where does 23 go to? 23, there's a 25, that looks like the next. So 25 is in 755. So I'm pointing this node to memory location 755, where I find a 25. What's the next highest number? Anything else in the 2s? There seems to be 25, so should be pointing to, looks like a 31. So that is memory location 757. 31. Where is 3100 pointing to? Looks like it's pointing to 3500, which is 753. So this should point to 753. When I'm at 753 of 35, the next highest number looks to be 41. So 35, this memory location 753 should be pointing to 754. When I'm at 754, I'm at 4100. 4100, the next highest number is 4800, which is in 751. When I'm 751, then it's pointing to the highest number, which is in 756. When I'm at 756, I've got a row value. That's it. We finished the linked list. So that is updating the pointers, this idea of pointers. And the second question, well, we've got a bit of theory. Explain the difference between searching for that. Look, the key difference here is if it is ordered, you can stop the search. You'll know if it's not there. If your element is greater than the next search element, you know to break out of the search. So this idea, if you'd explained that an unordered list, you will have to search all the values. If it is ordered and the value is greater than your search criteria, you can break out of the search. So the big difference are ordered lists are more efficient to search. Next, again, another question. We're updating our nodes. What's happening this time? So again, complete the table for next pointer 1, ascending alphabetical order. So it looks like Ahmed would be the head of the list, would be pointing to 2. So where does Ahmed point to? A would point to B, which is memory location 5. So I've got Ahmed pointing to B. Is there any C's? B is going to point to B, C, D, E, F, G, H, I, J. It looks like J. B is going to point to 1. J is going to point to L, which is, sorry, my mistake. Let's just rub that out. We've got Ahmed is pointing to Brown. Brown is pointing to Jones. Jones is pointing to Lewis, which is location 3. Lewis is pointing to Smith, which is location 0. Smith is pointing to Thomas, which is location 4. Thomas is my rogue value, and that should be the last element in the array. So the next question asks to add Murphy and Collins. So I'm going to do this one at a time so we can see the updates. So let's look at the algorithm for adding an element to a linked list. We said before that it's constant time. So we're going to add in Murphy. I've got to find where Murphy should be inserted into the list. I need to look at who's before Murphy alphabetically. Lewis should point to Murphy. So what I'm doing is I'm updating Lewis's pointer to point to Murphy. So Lewis is going to point now to 6, and Murphy is going to take Lewis's pointer, which is pointer 0. So we've inserted Murphy and we're just copying the other pointers across. The question isn't complete, but 4, 3, 5, rogue. Next we have to put in Collins. So I'm going to add in Collins, and let's look at where Collins goes. Collins will be fitting in after A, which is Ahmed, after B, which is Brown. So Collins is going to fit in after Brown. So we've got to look at Collins. Collins is going to take Brown's pointer, which was 1, and Brown now needs to point to Collins' location, which is 7, and the other locations remain the same. And there we have our final answer. So the final question is complete the pointers to delete Smith. And we said in theory class that, well, we don't really delete them, we just update the pointer. So Smith needs to be bypassed. So I need to find the element that comes before Smith and point it to the element after it. So when we look at what was pointing to element 0, it is Murphy. We've got to update Murphy's pointer to take what Smith was pointing to, and Smith was pointing to 4. So we're updating Murphy's pointer. It's going to point to 4. And I can ignore Smith in this. And we've got 3, 5, 6, well, sorry, a rogue value, 7 and 1. And we've updated the pointer to remove 3, 5, 6, rogue, 7, 4, 1 to remove Smith. And you could iterate through it, traverse through the array to sort that, traverse through the linked list to check that. That's, folks, linked lists. Next week we are going to look at binary search trees, and we will be meeting on Wednesday at 9 o'clock. I think I already posted that on the classroom. So go through the video, make sure you grasp what a linked list is, its advantages, its disadvantages, how to traverse through it, and how to add and delete nodes from a linked list, and in particular how to be able to implement it in an array, just like you did in the last question there, that you could store all that data in a 3-dimensional array. So have a good weekend, folks, and we'll chat next week.